Hi children and hi everyone. In previous video I explained about the Coulomb's law in general equations and Coulomb's law in vector form. In this video I am going to explain one more important topic, very important topic for examination point of view for intermediate second year children. So that's why children you have to watch the video up to last without skipping. And here from my side one request is there, up to now you didn't subscribe my channel, then subscribe my channel and press the bell icon to get the latest notifications. So now I am going to topic now. Today topic is electric field intensity. Electric field intensity, and we want to find out the electric field due to a point charge in this topic here. So very important topic children, don't forget to watch carefully. So children, in Coulomb's law I explained what's that. The force of attraction between two charges is directly proportional to the product of their charges and inversely proportional to the distance between the two charges. So similarly we have compared the Coulomb's law with the gravitation law, universal law of gravitation. So here now the Coulomb's law and gravitational force, law of gravitation, both are explained about the forces, and those forces are the central force. So after these two, Michael Faraday give one field theory. According to his concept, there is some electric field. What is mean by electric field? Electric field is nothing but, this is a first you have to know about the what is electric field. Here for example, this is the one charge. This is the one charge. So here according to the field theory, there is some space. There is some space around the charge. The space around the charge. Here in case of gravitation, the body which is having certain mass in its surrounding, that should be affected the another one. That means that should be attracted the another body. Like that. Here also the charge is there, around this charge some space will be there. In that space there is some influence of this charge. The space around the charge which is in its influence is called electric field. Clear? How we can observe the influence of the field means simply here, this is a charge we are taken, and around the charge there is some space is there. That space here nothing but its field. That means the influence of charge should be available in this field only. That means if you can keep some other charge, out of this boundary, there is no, for example I am taking this is the plus charge and we are taking some, this is the plus charge. Clear? Here this is the plus charge and this is also plus charge. Here when for example I am taking this is q dash, I think so. Here the q dash we are taken, when this q dash is out of this boundary, then it is not attracted, not repulsed by this charge. That means you can take either it is plus or minus. This is plus or minus. If you can take plus q charge, q dash, then it should be repulsed, and if you can take minus q dash, that should be attracted. That means while we are taken one plus q is the charge, around that some space is there. If you can keep some other charge out of the boundary, it was not attracted, not repulsed. That means there is no influence by the plus q charge. But if you can keep the same charge that should be here, that means maybe repulse, that should be repulse. If you can take negative charge, that should be attracts. That means what? Within this boundary only this charge will be affects another. Out of the boundary there is no effect of the plus q. That means this is here called field concept, nothing but electric field. Simply the space around the charge which is in its influence, that should be called electric field. Clear children? This is the electric field. The space around the charge which is in its influence is called simply electric field. Clear? Now you want to know about the electric field intensity. What is mean by electric field intensity? So electric field intensity, generally electric field intensity should be shown like this. E is equals to F by Q naught. E is equals to F by Q naught. Here F is the amount of force and Q naught is the positive test charge. Positive test charge. The charge is here Q naught and F is what? Force. The force experienced by unit positive test charge. Unit positive test charge in an field. That should be called electric field intensity. Got my point? The field here we are taking electric field. In that, if we can give any charge, that should be experience some force. Because already we know that like charges always repulse. That means there is some repulsive force between like charges and there is some attractive force between the unlike charges. So already electric field means what? The space around the charge. That means the field belongs to particular charge. Clear? So in that field, if you can keep some other charge, then that should be automatically affected. That means either it is repulse or it should be attracts. Clear? That's why electric field intensity can be defined as the force experienced by unit positive test charge when it is placed in the field of one particular charge. Just see here. Now simply same example we are taking now. This is the space around the charge of, I am saying now this is Q here. At this point here we have positive charge Q. Clear? And from that particular distance, at particular distance we are keeping now Q naught. What it is? Q naught. Clear? This is what? That circle is what? Electric field of Q. Electric field of Q. The circle is what? Electric field of Q. In that, at particular distance from the charge, you are keeping some charge here Q naught. Here Q naught is what? Test charge. The test charge must be always taken positive. Here, when we are taking like that, here there is some force. There is some force acting on this Q naught. There is some force acting on Q naught because of this electric field. That amount of force here, what we call electric field intensity. Got this point, children? Already we have what it is. Q is the charge and this boundary circle what it is? What it is? Simply it is now field of Q. In that field, here we are keeping some Q naught. Q naught is what? Positive test charge. On that, some force will be acts. When Q naught is kept inside this one, that should be there some force acting on the Q naught. That is what we call electric field intensity. Clear? Electric field intensity. Clear now? So what is electric field intensity? The force experienced by the charge when it is placed in an electric field. Clear? And now here the electric field intensity. Electric field intensity is a vector quantity. What's that? Electric field intensity is vector quantity. For example, if you can take this is the plus Q charge, then electric field intensity should be like this. In this direction. Outward, radially outward, radially outward. If you can take minus Q, now radially inwards, radially inwards. So that's why here, how we can identify that? From the charge, electric field intensity is radially outward, outward. That means what? This is the plus Q. If you can take minus Q charge, for that the electric field intensity is in the radially inward. Don't forget this one, important. For a positive charge, the electric field intensity is radially outward. For negative charge, radially inwards. So now here electric field intensity is a vector quantity, and for positive charge it is radially outwards, for negative charge it is radially inwards. And now in this case, here now units and dimensional formula. Units and dimensional formula of electric field intensity. So now here I am writing units here. For force what you write? Newton. For charge what you write? Coulomb. Newton for coulomb is the unit for electric field intensity. And now dimensional formula. For force what you have? F is equals to mL T inverse 2. mL T inverse is the dimensional formula of force. And here I is equals to Q by T, and Q is equals to what? IT. Q means what? Charge. IT. For current what is dimensional formula? A. And time T. That's why I am writing here E is equals to F means what? mL T inverse 2 by A into T. A into T. Then what you get? Electric field intensity dimensional formula is what? L T inverse 3 A inverse 1. So this is the dimensional formula of electric field intensity. Got my point with this, children? So this is simply about the electric field intensity and its units and dimensional formula. Electric field intensity means what? Electric field intensity is nothing but force experienced by the charge when it is placed in the electric field of other charge. Clear? It is a vector quantity. Units are Newton for coulomb, and this is what? Dimension formula mL T inverse 3 A inverse 1. Clear, children? So you have to know that the electric field intensity is E is equals to F by Q naught. And now here in this case there is some proportionality is there. F is proportional to Q naught. F is proportional to Q naught. These two are directly proportional. Clear? And after that you have to say that here already I told you what is that? Q and Q naught. This is the charge and Q naught is the test charge. In that field we are keeping, that means Q can affect the Q naught, but Q naught cannot be affects the Q, because the intensity of Q is very high and does not. Here simply what you have to say, in this case Q must be independent of Q naught. Q must be independent of Q naught. So children, so this is about the simply about the electric field intensity. So up to now you learned two definitions. One is what is electric field and what is electric field intensity. Electric field means what? The space around the charge which is in its influence is called electric field. And what is electric field intensity? The space around the charge. The space around the charge in its influence is called electric field. Electric field intensity means what? In that electric field there is some force acting on particular one charge. That is what we call electric field intensity. Clear? Now 4 marks important question. Define electric field intensity due to an isolated point charge. Due to an isolated point charge. Children, watch carefully. Very important topic. Here now again, what is the electric field intensity? You can write what is that? Electric field intensity is equals to E is equals to F by Q naught. F by Q naught. And here electric field intensity due to an isolated point charge. Isolated point charge. For that we have to write the explanation like this. Here this is the one point O. At that point we have some charge is there Q. What is the charge? Q. And in that electric field of this one Q, we have selected one point. That point is at a distance from R. At a distance of R from the Q. Clear, children? We have taken one charge Q. So for that charge one electric field is there, because in the space around the charge is called electric field. Clear? That's why here Q is having some electric field. Clear? This is here I am taking positive charge. That's why I am showing electric field like this. Clear? Don't confuse. Electric field intensity also sometimes called as simply electric field. Clear? electric field intensity should be in this direction. And now here in the electric field of Q, we have selected one point. Clear? Let us consider PBA point in the field of Q at a distance of R from the charge. Clear? Then we have to keep one charge Q0. Clear? What we say? We have taken one charge Q, the electric field of charge Q, in that we have set one point. That point is what? P. That point is which at which distance of R from the this one, from positive charge, that should be at a distance of R. There we have to keep, we want to examine the electric field intensity at this point P. Clear? P is the one point in the electric field. At that point we have to identify the electric field intensity. For that purpose we have to keep one charge Q0 at this point. Clear? Now according to Coulomb's law, here Q is the one charge and Q0 is the another charge. What is the importance of Coulomb's law? Coulomb's law simply explain about the force between two charges which are separated by some distance. In this case, here Q and Q0 both are separated. And how much distance are these two are charges and they are separated. That's why we have to say the force between two charges by using Coulomb's law. So that is what you are writing. Here I am writing F is equals to what? Right, 1 by 4 pi epsilon naught. What is epsilon naught? Permittivity in free space. So here we are writing F is equals to 1 by 4 pi epsilon naught Q naught by R square. So this is the equation number 1. By using the Coulomb's law, we are writing the force between two charges. That is what? F is equals to 1 by 4 pi epsilon naught Q naught by R square. Equation number 1. After that, here Q is in numerator. If you want to bring this side, how we can write? F by Q. Or I am writing here, sorry, F by Q naught. I am bringing Q naught. Then what to write? 1 by 4 pi epsilon naught into Q by R square. What is that? Q by R square. So here we are bringing Q naught this side. And what to write? F by Q naught is equals to 1 by 4 pi epsilon naught Q by R square. Then here what is mean by F by Q naught? That is what? Electric field intensity. So here I am writing E is equals to 1 by 4 pi epsilon naught Q by R square. So why? Because since F by Q naught is equals to what? E, electric field intensity. Then E is equals to what, right? 1 by 4 pi epsilon naught Q by R square. This is the equation for electric field intensity at a point P because of Q. What, right? E is equals to 1 by 4 pi epsilon naught Q by R square. Clear, children? And now here in this case I am writing the relation should be like this. Simply Q is the constant amount of charge and 1 by 4 pi epsilon also constant. Then what do you write? In this case we can write E is proportional to 1 by R square. What, right? E is proportional to 1 by R square. So this is the relation between the electric field intensity and distance. Clear now? Simply look here, electric field intensity due to a point isolated charge. So here this is the charge Q in the field of Q. We are selected one point, that should be P, a distance of R. Now at this point we have to check the electric field intensity. Then we have to keep charge some Q naught. For that, by using Coulomb's law, we can write F is equals to 1 by 4 pi epsilon naught Q naught by R square. From that, we are bringing Q naught this side. Then what it is? F by Q naught is equals to 1 by 4 pi epsilon naught Q by R square. Here, this value means what? E. Then E is equals to 1 by 4 pi epsilon naught Q by R square. This is the relation between electric field intensity due to the isolated point charge. Clear children, very important. We discussed electric field intensity due to a point charge. For example, if the system consists of number of charges, then how we can write the resultant electric field intensity? The system consists of number of charges, then how we can write the electric field intensity? See here once. For example, this is the system we are taking. This is now one system simply here. In that we have some charges there, Q1, Q2, Q3 and Q4. 4 charges are there. Just imagine we want to find out the electric field intensity, resultant electric field intensity at this point P. Here the system consists of 4 charges. Now we have selected one point in that system. At that point we have to find out the resultant electric field intensity. Clear? Now in this case, here the distance between these two is here R1 and these two here is R2. Distance from point to the charge Q3 is R3 and distance from charge point to the charge Q4 is R4. Clear? This is the point here. Yes, from selected point Q1, Q2, Q3, Q4 are at the distance of R1, R2, R3 and R4. Now in this case, from Q1 to this one, in this side we have electric field intensity, that is E1. Clear? For that E1, what we can write? E1 is equals to 1 by 4 pi epsilon naught Q by R square. This is the general formula. In previously what I explained, Q naught are there, then what you get from that equation? E is equals to 1 by 4 pi epsilon naught Q by R square. This is the electric field intensity due to a single point charge. So if you can consider only Q1, that should be similar to that only. That's why I am writing now the electric field intensity due to the Q1. Due to the Q1 is what you write? E1 is equals to 1 by 4 pi epsilon naught Q1 by R1 square. Equation number 1. And with respect of Q2, what write? E2 is equals to 1 by 4 pi epsilon naught Q2 by R square or R2 square. This is the distance of R1. That's why I am writing R1 square. And this is the distance of R2. I am writing R2 square. And similarly for electric field intensity of Q3 charge at the point is given by E3. E3 is equals to 1 by 4 pi epsilon naught Q3 by R3 square. Now this is equation number 3. Clear? And now same thing, electric field intensity at this point P because of Q4. What do you write? Because of Q4. What do you write? E4 is equals to 1 by 4 pi epsilon naught Q4 by R4 square. Now I am showing the directions now here. This is what electric field intensity due to the Q1, and this is what in this direction what you have E2, and this is what E3, and this is what E4. So we are taking all our positive charge, that's why radially outwards. So E1, E2, E3, E4 we are taking. At this point P we have E1 is what? Electric field intensity because of Q1. And E2 means what? Electric field intensity at this point because of E2. What is mean by E3? Electric field intensity at this point because of Q3. And what is E4? Electric field intensity at this point because of Q4. So those should be written as like this. Now the resultant electric field intensity is nothing but here. Already told you electric field intensity is the vector. That's why by using the law of vector of addition, we are getting the resultant electric field intensity E1 plus U2 plus E3 plus and E4. The electric field intensity at this point, what do you write? The addition of the algebraic sum of individual electric field intensities at this point is gives the resultant electric field intensity. Very clear, children. We have taken one system. That system consists of 4 charges: Q1, Q2, Q3 and Q4. Clear? So we are select one point P. From that point they are a distance of R1, R2, R3, R4. Then E1, E2, E3, E4 are their respective electric field intensities. So already we have for this one is what? Electric field intensity formula is what? Q by R square. E is equals to 1 by 4 pi epsilon Q by R square. This is the general formula. So for that's why here first we have to write individually to the Q1, Q2, Q3, Q4. Then if you can take Q1, it is also nothing but this is a single charge. And this is the point what selected. This is what? Electric field intensity of Q1 at point charge. So this is E1. And electric field intensity due to Q2 at this point. And this is E2. And similarly E3, E4. Here by combining all of them, what we get? Resultant electric field intensity at that point E. That is what we write. Simply just we have to substitute down. E is equals to, we have to substitute there. E is equals to, simply I am writing 1 by 4 pi epsilon into Q1 by R1 square plus Q2 by R2 square plus and Q3 by R3 square plus and Q4 by R4 square. So this is the resultant electric field intensity. Children, I hope you understand. If you can understand the topic, like, share the video and press the bell icon and subscribe my channel. So if you want to expect more videos from me, just support me by subscribing my channel. Okay children, bye, take care. We will meet in the next video with another topic.